So we talked about in the last video these percentage problems. In this video, we're going to talk about related sums problems, or what I'm calling related sums problems. Now, you can see an example of a related sum problem on these instructor-led problems, number 15 here. A total of $20,000 is to be divided between Jack and Diane, with Jack to receive 2,000 less than Diane. How much will each receive? So what we see here is there's an amount and it's split between, in this case, two people. All right. Now, why I call this a related sum problem is related sum problems are always going to be starting out with two objects, two values. Let's call them A and B, adding up to some total. All right. And then that's the sum part. The two amounts add up to a total. The related part is that these A and B have some sort of a relation between each other, or maybe the A and the total have some sort of relation between each other. But usually in this section, A and B have some sort of relation between each other. So let's look at the Jack and Diane example here. So we know a total of $20,000 is divided up between the two of them. Basically, that means the amount that Jack has plus the amount Diane has is going to add to $20,000. The second part of this problem says Jack will receive 2,000 less than Diane. That gives me a relationship between the amount that Jack has and the amount that Diane has. So that's the idea. So there's a sum and there's a relationship between the two quantities. So let's actually create this. Now, when you do this, when you're creating a related sums part, I always start with this A plus B equals total formula. Now, I'm not always going to use A and B. For instance, in this case, I'm going to use J and D for Jack and Diane. So Jack and Diane together are going to receive $20,000. So I'll write J for the amount Jack has and D for the amount Diane has. Now here's where the relationship gets into or comes into play. Jack will receive 2,000 less than Diane. Now you can do this in a number of ways, but what I'm going to do, since Jack is going to receive 2,000 less than Diane, what I'm going to do, I'm going to put Jack in parentheses. I'm going to keep this equation the same other than putting parentheses around the amount Jack has. Now, Jack is going to receive 2,000 less than Diane. Think about what 2,000 less than Diane means. 2,000 less than Diane can be represented by taking the amount that Diane has and taking away, subtracting 2,000. Now here's the key. That's the amount Jack has. So 2,000 less than Diane is basically saying I can replace the amount Jack has, the J, with a D minus 2,000. Okay? And now I have an equation in one variable. That variable is obviously D. And so I can solve this equation for the D. All right? So this is how you're going to do, or how we're going to do every related sums problem like this. So here we go. There's nothing to distribute here, so you get D minus 2,000. plus D equals 20,000. D and another D, those combine to give me 2D. If we're solving this, normally I'd add 2,000 to both sides. So add 2,000 to both sides. We get 2D equal to 22,000. And then divide both sides by 2. When you divide the left by 2, you just get D. When you divide the right by 2, you get 11,000. So there you go. D equals 11,000. Now what that means is that the amount that Diane is going to get is 11,000. All right. Now how much is Jack going to get? Well, you can solve this in a couple of different ways. You can say that Jack is going to get 2,000 less than Diane. So now we know Diane has 11,000. Subtract 2. That means Jack gets 9. At least Jack gets 9,000. The other way you could have done that is plugged in the D as 11,000 here and solve for J. J plus 11,000 equals 20,000, and then subtracted 11,000 from both sides. So either way, we see that Diane gets 11,000 and Jack gets 9,000. All right. So that is how we solve a related sums type problem. Now, related sums type problems can look a lot of different ways. All right, number 16 is also a related sums type problem. Let's go over that one right now. So number 16 says two brothers, Joe and Bob, sold 104 tickets for a school fundraiser. Joe sold 20 more tickets than Bob. How much did each brother sell? Okay, so we have Joe and Bob. They sold 104 tickets total. And the relationship between them is that Joe sold 20 more tickets than Bob. So we're going to treat this the same way. All right, let me start a new page that I can do this. So we say Joe and Bob. I'll write J for Joe and B for Bob. So a total of 104 tickets. Okay. Total of 104 tickets for a school fundraiser. Joe sold 20 more tickets than Bob. So Joe, that's the one I'm going to put in parentheses because it's written that way. Joe sold 20 more tickets than Bob. Now, 20 more tickets than Bob would be a B plus 20. So I'm going to replace this J with a 20 more tickets than Bob, a B plus 20. But remember, I still have to keep this plus B equals 104 as well. So there you go. By the way, when I'm looking for an equation on the test, if it says write an equation, I'm looking for something like this. Okay, that step there, B plus 20 plus B equals 104. So I'm looking for an equation with one variable. In this case, I use B. If you want to use some other letters, X's and Y's, that's fine too. So there we go. These parentheses don't matter a whole lot. B plus B is 2B plus 20 equals 104. Subtract 20 from both sides. We end up with 2B is equal to 84. And then divide both sides by 2. You end up with B is equal to 42. So what that means is that Bob would have sold 42 tickets And since Joe sold 20 more than Bob, add 20 to 42, he must have sold 62 tickets. Joe sold 62 tickets. There you go. And notice that we can check that these are the right amounts in that we know that Joe sold 20 more. There's a difference of 20 there, but also that they have to add up to 104. If you add up 42 plus 62, they do in fact add up to 104. So there you go. That's how to solve that related sums type problem. Now there's a couple of other related sums type problems here. Um, Dealing with consecutive integers and consecutive even integers. These are related sums, but just a little bit in disguise. Let me explain what I mean by that. So let's take a look at number 17. It says the sum of three consecutive integers is 165. Find the numbers. So three consecutive integers, a sum of three consecutive integers is 165. Now this differs a little from the first two problems that I did because I had two amounts adding to a total. Here we're saying the sum of three consecutive integers. So the sum of three consecutive integers, well, we need to be adding up three numbers. Okay? And obviously that sum has to add up to 165. So 165. Now, the related part comes from the fact that they are consecutive. Okay? So let me explain what I mean by that. So earlier we had relations of like Joe was 20 more than Bob, or Diane, or excuse me, what was it? Jack was 22,000 less than Diane. So consecutive means in a row. So if I have consecutive integers, it would have been like 9, 10, 11. Those are three consecutive integers. Another three consecutive integers would have been 34, 35, 36. Another three consecutive integers could have been 109, 110, 111. All right? Now, notice what's going to happen here, that if I know the first number, we'll call that A. We'll call A the smallest one. Then I can get the next number by adding 1 to A. And I can get the third number by adding 2 to A. So the relationship comes from the fact that I can replace this B and I can replace this C with expressions of A. Let me explain again. So B, the second number, has to be 1 more than A. And the third number has to be 2 more than A. In order for those to be consecutive integers, I have to have that. And there you go. That's an equation in one variable that I can solve. So by the way, A plus A plus 1 plus A plus 2, these parentheses you can drop off, and we get combining like terms A plus A plus A, that's 3A. 1 plus 2 is 3. So I end up with 3A plus 3 equals 165, and then I do my normal solving. 3a equals, well, subtract 3 from the left, subtract 3 from the right, you get 3a is equal to 162. Then I can divide both sides by 3, and I get a equals 54. All right, so consecutive means in order. Now remember, the question asks us to find all three numbers. So we would say the three integers are, well, we know the smallest one is 54. The next one has to be one more, so that has to be 55. And the third one has to be two more than the 54, so that one has to be 56. So the three integers are 54, 55, and 56. And by the way, you can double check that. There are three integers that are in a row. And also, if you add those up, you should end up with 165. So there you go. Now again, what I'm looking for is practice writing these equations. That's the big thing for me. For me, I want you to be able to translate the problem into an equation. So make sure you're doing that each time. Don't try to outthink the problem. Don't think that, well, I can get the answer a different way. Again, that's not what this class is about. This class is about doing some algebra and coming up with an equation. Now, the last problem that I'm going to do on this video is number 18. The sum of three consecutive even integers is 78. Now, this is going to be very similar to this. Very similar to this problem here, except now we have consecutive even integers. Consecutive even integers. So we're going to take a plus b plus c is equal to 78, but I want consecutive even integers. By the way, what is a consecutive even integers? It's like 8, 10, and 12. So instead of jumping to the next number, whole number, which is from 8, which would have been 9, I jump to the next even number. So that's a 10. So you skip over the 9, get to a 10. Then you go from 10, skip over the 11, get to a 12. So consecutive even integers, you're jumping by 2 instead of by 1. So when we go to write our equation, my second number, b, has to be 2 more than a. And you'll notice if you jump by 2 and then 2 again, that means my third number, c, would have had to have been 4 more than a. And now we have an equation that we can solve. So again, sum of three consecutive integers is 78. Find the numbers. This is the equation. A plus 2 plus a plus 4 equals 78. We can combine like terms. It gives me 3a, 3a plus 6 is equal to 78. Standard solving, subtract 6 from both sides. 3a, I keep doing that, 3a equals 72. All right, 72 obviously divided by 3. A is 24. So the three integers are obviously not 8, 9, and 10. That was just an example. But the smallest one is 24. The next even integer beyond that is 26. and the next even integer on that, beyond that, is 28. By the way, you can double check your work by just adding 24 plus 26 plus 28 and seeing that they do add up to 78. All right. Now, by the way, consecutive odd integers would have had the exact same property. Some people think, well, even you add to odd, you might have to add something different. No, consecutive odd integers, think of an odd number, let's say 33. My next odd number would be 35. My next odd number would be 37. So notice you still jump by plus 2 and then plus 4. All right, so you're still, odds and evens both are jumping by plus 2 each time. Okay. So I say that obviously because there's one problem. It's either in the cooperative group problems or the at-home practice problems or the graded homework, which has that property that they use odd instead of even. But odds are still jumps by 2. So there you go. Those are the related sums type problems. Again, it's very important, and I will be grading your ability to come up with an equation like this or an equation like this, which has a single variable and able to be solved. Okay, so make sure you pay special attention there. Other than that, I'll start on the geometry type problems in the next video.